This video is on how to solve a system of three variables using matrix operations. The first step is to change our system into a matrix. We have an augmented matrix here, and you'll see that I have it as rows 1, 2, and 3, and I wrote those in blue. And our goal is eventually to get this have this diagonal happening where we've got a diagonal of ones and all of the other elements in the square matrix to be 0. And so what will be the solutions will be this column here, this A, B, and C will be the solutions to the system. One of our first steps, because we're trying to get these ones, I want to get these ones, and so I'm looking for getting a 1 in this upper left corner, is if I just add equations 1 and 2, or actually rows 1 and 2, add those two rows together, you'll notice that all of a sudden I now have a 1 in the upper left. So that was a good thing. So I replaced that row 1 with the addition into now it's called row A. Now, if I take row A and double it and add it to row 2, what I'm going to be doing is I'm going to add it to get rid of this element right here, because I want to have zeros below the 1, because I want the column to be 1, 0, 0. So I'm looking at ways to make these two rows have zeros in the beginning. So if I multiply 2 times row A and add it to row 2, I now get a 0 there, and I'm going to replace that into row 2. And now I have a 0 in the beginning. And I'm going to do something similar here. I'm going to take rows 2 and 3 and add them together, and that's going to give me another row that starts with a 0. I'm going to replace row 3 with that. And so now I have these 3 rows, but in column 1, I have a 1, a 0, and a 0. So I fulfilled my first goal here. Now I just rewrote the same matrix that we just had, but now notice that the rows are called row A, B, and C because they've been changed. All the rows have been changed. And now, if I'm trying to figure out how I'm going to get some more zeros in here, and I was looking at -4 and -26, and I don't know how I'm going to do something to get rid of one of those or make them into a 1, but I do know that I could take these two elements, 11 and 1, and I could somehow use some multiplication and adding to get rid of those, and so that's what I did over here. You'll see that I did B minus 11C, and sure enough I got a 0 in here, so I wanted to get some more zeros. But not only that, but I noticed I've got 18 and 9, and I like that because they're both multiples of 9, but I want to get this element to be a 1, so if I divide everything by 18, I've got 0, 1, 0, and then a half. And I'm going to put that into row B. So I'm going to rewrite the matrix again down here, and you'll see that I've replaced it into row B, and now it's called Roman numeral 2 in blue, but I have a 0, a 1, and a 0. And if you go back, you go, oh, that was the goal that I wanted for row 2. So not only have I got the column 1 properly, I also have row 2 the way I want it in the final addition. So I'm looking at that and I'm thinking, well, if I utilize row 2 and row C, I could get rid of this -4 by multiplying row 2 by 4. So when I do that, I get 0, 0, 1, 5. And I'm going to replace row C. When I replace row C, I'm really happy because I replaced row C with this blue Roman numeral 3, and I have exactly what I needed, what my goal was for row 3. The only thing that is not what my goal was is row 1 has a -10 and a 4. But if I were to multiply row 2 by 10 and row 3 by -4, I will now have opposites of this -10 and 4, so add that to row A, and when I'm done I have a 1, and then I have those 2 zeros, and then a 4, so I'm going to put that into row A and call it Roman numeral 1, and I have exactly what I wanted for my goal. What I have is, I have a diagonal of 1s, and all the other elements in the square matrix are 0. That means that this final column, the column right here, these are my solutions, which means x equals 4, y equals 1/2, and z equals 5. And the other way we know to write the solutions is as the ordered triplet, 4, 1/2, 5. And that's solving a system of 3 variables using matrix operations.